Hey guys, this is our next notes video. This is about the period of sine and cosine curves. This works the same for both kinds of graphs. And so we're going to just interchange them back and forth. We're going to do some examples of each one. And then I'm going to go ahead and do one problem from the homework sheet. And so the homework sheet, it looks like this. So you have this note sheet that you can see in front of you, and then this is the homework sheet that was posted with it. So if you have this handy, or if you don't have it handy, you want to grab it because we're going to do the first one together just for practice with more graphing. And so make sure you have this so that you can follow along with that. And so let's start the notes. And so we have talked about frequency and we have talked about amplitude. And now we're going to go and talk about the next thing, which is the period of a graph. And so the first part is a little bit of review and just getting some different terms. And then we'll talk about at the last couple bullet points are the new part. And so in the equations, y equals a times sine of bx, or y equals a cosine of bx. So you can see we have a, from other functions that we've talked about, that we put different letters in to represent numbers. So a lot of times with regular functions, we use an h and a k as placeholders for different numbers. So like in a real function, a would be a number and b would be a number. And we've actually talked about both of those already. So these things are true about basically what we're saying is that in these functions, these statements are true. And so if you have sine of x or cosine of x, the graph of the sine of x crosses the x-axis at the origin. Okay, now that's true because these are not shifted vertically. And so when we start talking about a vertical shift, it won't cross at the origin, it'll cross at its starting point. And so, or its midpoint. And so that's specific to these functions that don't shift in ways that we haven't talked about yet. The graph of cosine of x does not cross at the origin. We have talked about how cosine starts up at its midpoint. Or excuse me, no. Cosine starts up at its highest point. Sine starts on the middle line. The shape of the graphs of sine of x and cosine of x are the same, but are shifted from one another. So I mentioned this both in the Zoom meeting and in that first video, and I showed you them together. They're really the same. The shape is the exact same. They are just shifted horizontally, left or right. We'll talk about that when we talk about shifts, but we would say they are shifted from one another. The A, so up here where we have the A stands for the amplitude. So we've talked about amplitude already. And that determines the height of the graph you can add this, let's call it the midline. So from its midline, which so far for us has been the x-axis. All of our graphs, both sine and cosine, have been centered across or around the x-axis. The B, so the B is in the spot where we have been putting the frequency. So B is for the frequency. Okay, and determines the number of complete curves between 0 and 2 pi. So that's basically what we've been talking about, but instead of using F, they're using B. That's just kind of the generic standard letter that we've used. Like how in a parabola, we always use H and K. In a circle, you don't know this, but we use H and K there as well. Here we use A and B. That's just what we do. Okay. I am still fine with you writing like you did on yesterday's homework, with you writing F equals whatever for frequency. You can also write B. They're interchangeable. I'll know officially it's B. I'll know what you mean if you put F though. Okay, so this is new, the period of the graph. So far we've talked about amplitude, that's its height above and below the midline. We've talked about frequency, which is how many complete curves you get between 0 and 2 pi. And so the period of the graph is how long it takes to get one complete curve. So the period of the graph is how long it takes to get one complete curve. So the period and the frequency actually work together. The frequency tells you how many curves you get between 0 and 2 pi. And then the period tells you how long it takes to get one curve. And so we actually were, when we were graphing in that Zoom meeting, we were technically finding the period. When the frequency was 4, and I said, to figure out where 1 stops and starts, you could just take 2 pi and cut it into fourths. That was us finding the period. I didn't call it that because you didn't know that yet, but that's really what we're doing. So the period to find the period of the graph, we do 2 pi divided by b. So essentially 2 pi divided by the frequency. Having some trouble writing neatly today. Okay, so for these first 4 on this note sheet, we're not going to actually graph them. We're just going to go ahead and find the 3 things, and then we'll go and do the first problem on the homework, and we'll actually graph that one. So for this first one, we have y equals 3 cosine of 1/2 x. We could have used theta here, okay, and that would have been fine too. They kind of go back and forth. You see theta most of the time, but you do see x sometimes. The amplitude is this number out front. So the amplitude is 3. The frequency is the number with x, so the frequency, so f equals 1/2, or you could put b equals 1/2. Either one is acceptable. And then to find the period, listen, some of you are just going to be able to do this in your head. You're just going to get it. Some of you are going to be like, oh, if the frequency is 1/2, the period has to be blah, blah, blah. And you're just going to know it. Some of you aren't, and that's fine, okay? I don't want you to feel like you have to just know what it's supposed to be. So we're gonna take, for the period, I'm gonna write this down here, I'm gonna do 2 pi divided by the frequency, which is 1/2. Okay, which this is equivalent to 2 pi divided by 1/2. This is 2 pi over 1. When you divide fractions, you flip the second one. So 2 pi over 1 times 2 over 1, which is going to be 4 pi. So the period is 4 pi. Okay, and in when I do the homework, I usually just write the word period, to be honest with you. There's not really an abbreviation for that. I just write period is 4 pi. All right, let's look at this next one. Here we have y equals 1/2 sine of 3x. So the amplitude is the number out front. It's the 1/2. The frequency is the inside those parentheses with the variable, which in this case is x. So we would say f equals 3 or b equals 3. You just need one of those, whichever one you prefer. I'll accept either one. I go back and forth. So on some of my answer keys that I give you, sometimes it'll say b and sometimes it'll say f. For period, we are going to do always 2 pi divided by the frequency, which is 3. So this is 2/3 or 2 pi over 3. There's nothing to simplify there, like the last one. Okay, let's look at these bottom 2. Number 3 is y equals -5 cosine of 6x. So the amplitude is the number out front. So -5. Actually, no, that's not right. It's just 5. The amplitude is 5. The fact that it's negative, we talked about this a little bit in that first video, means that it's going to be upside down. So instead of starting up and going down, it's going to look like this. This one is going to start down and go up. So it's going to be upside down. But we don't say that the amplitude is negative. The amplitude is a height or a distance. It's how far it is from the middle. And so we wouldn't say -5. So for the amplitude, you just say a 5. But then when you go to graph it, you need to draw it upside down. Okay, so instead of starting high, it'll start low. We'll get some like that. There's none on your homework like that, negative today, but we'll do that eventually together. The frequency is the 6, so b equals 6, or you could write f equals 6, whichever you would like. And the period is 2 pi divided by the frequency. You do want to reduce that, so this reduces to pi over 3. 2 over 6 is 1/3. So we would say that the period is 1/3, or excuse me, pi over 3. The next one, the amplitude, or excuse me, I'm sorry, y equals negative 1/3 sine of 2/3 x. We would say that the amplitude is the 1/3. Again, this one is negative, it's a sine. So if you were graphing this one, because it's negative, it would be upside down. So instead of going up first, it's gonna go down first. So it's gonna look something like that. Okay, so it's just gonna be an upside down version, but the amplitude itself is just 1/3. Your amplitude is always positive. Okay, these are like two different things. We have the negative and we have the 1/3. They don't go together. Okay, the frequency is the 2/3. So B equals 2/3 or F equals 2/3. Please remember we talked about this on your last homework in that Zoom meeting when we did it, but sometimes they'll write this as 2x over 3 instead of writing 2/3 and then x. So you just make sure you understand that these mean the same thing. And then the period is always 2 pi divided by the frequency. So 2 pi divided by 2/3. So we would flip that second fraction. So this is essentially 2 pi over 1 times 3 over 2. Okay, so this is 6 pi over 2, which is 3 pi. So what this means is that it takes 3 pi units across until you get one complete sine curve. So if this is your graph, okay, where it ends right here, this is 3 pi, is what we're saying. Okay, this one, I'm just sketching so you can see the period part of it. This one, this -5 cosine of 6x, it had a period of pi over 3. So it's gonna look something like this. Okay, you might have a bunch of them, but oops, right here, where this first one ends, is pi over 3. So you might have a bunch of curves, but what we're saying is that it takes you until pi over 3 to get a period, or to get one complete curve. So the larger the frequency, the more you have between 0 and 2 pi, the smaller the period is going to be. I mean, because if you have a bunch of them, then it takes less time. They're really skinny, and it takes less time to get a complete one. Okay, let's just practice. Let's do on this graph. This is your homework sheet. So let's do the first one just so we can get some practice with graphing together. So let's do. Let's write these down. Okay, so I'm gonna say, let me make sure I remember. Okay, so I'm gonna say the amplitude, so we have y equals 3 cosine of 2 theta. And again, this worksheet generator does not put parentheses. So the amplitude is 3. The frequency, I used B, but you could use F, is 2. So we know this means it's gonna have, by the time you get to 2 pi, you will have completed 2 complete cosine curves. So the frequency tells you how many complete curves you get between 0 and 2 pi. Okay. The period then tells you how long it takes just to get one. So we do 2 pi divided by the frequency, which is 2. So the period is pi. So that means by the time we get to pi, we should have one complete curve. Okay, so let's do this. We know that cosine starts at the highest point, so that's going to be 3. So it starts at 3. It's going to end its complete curve at pi, also at its high point. So at pi, it's going to be up here at 3. In the very center, cosine is at its low point, so -3, because you go 3 down from the middle, which for us is the x-axis. In between these first 2 points, so 0 and pi over 2, it's going to cross. So at pi over 4, it crosses. In between these last 2 points, it's going to cross. So it crosses right here. So you remember, you have to make it curve. It's not going to, you have to add that, okay? And it does count, okay? Making sure you get that in there. I always recommend, I'll see it like that's too much. I always recommend using a pencil for this. Okay, there's one complete curve. Now you have to fill the graph, so you have to keep going. So this one ends at pi, so our next one starts at pi. The period is pi. So if you're at 1 pi, the next one is going to end at 2 pi. So it's going to be up at 2 pi. Right in between pi and 2 pi is 3 pi over 2. So it's going to be at its low point at 3 pi over 2. Right in the middle. Remember, it's all about middle. So this is how I do it every time. I mark the beginning and the end, find the middle. Then I find the middle of these two, which is 5 pi over 4. The middle of these two is 7 pi over 4. And then connect them, making sure you're adding the curve. You can like finish this off this way if you want to, but you don't have to. Actually, I'm going to erase that just for now. You're welcome to do that. I'm not going to require you to do that. You have to go to the last marked thing for sure. And so what I want to point out really quickly, and then we'll be done, is we said that the frequency was 2. So we said that between 0 and 2 pi, you should have 2 complete cosine curves, which we do. Here's 1 and 2. Okay, we said that it would take pi units to get 1 complete curve, which it did. 0 to pi, you get 1. Please be quiet. Pi to 2 pi, you get a second one. Sorry, everybody. We're getting a little restless over here. Okay, so hopefully that makes sense. I'm going to leave you to do 2, 3, and 4. Please, please, please let me know if you have questions or if you need help, and I'm happy to help you. Please try to be neat when you're graphing. I don't expect yours to be as neat as mine necessarily. I've been doing this for a while and you're just starting, but please do the best you can to try to keep your graphs neat and looking organized so that I can tell kind of what's going on. And frankly, I need to see points, okay? Even if you're using your calculator to help you get the graph, you need to be marking things on here. Please do not just do this, okay? That is not gonna get you credit. I need to see that you know where it's high, where it's low, where it's crossing. Okay? I need to see those points so that I know that you really understand kind of how this graph works. All right, please let me know if you have questions. I hope that you're doing well, and I will see y'all soon. Have a good one.